All right, welcome to the second problem. In the first problem, we worked with a Poisson probability distribution, which, if you've been reading along in the textbook, you know is the probability distribution that that is ideal to use in the case where you're dealing with a discrete variable and you're also dealing with a rate. How many customers show up, every, so often, for a specific time interval, something like that. In this question, we're asked, at a bank, 3% of all customers in a given month are charged a fee for insufficient funds. In other words, they're charged an overdraft fee for overdrafting their account. In a random sample of 36 customers, what is the probability that exactly 2 customers will be charged an overdraft fee? So, in this case, anytime we're dealing with the probability of success or of failure, in other words, where there are only 2 options, in other words, somebody could overdraft their account or not overdraft. And think for a moment what type of probability distribution we'd be working with here. If you answered the binomial probability distribution, then you are correct. And recall that the probability, in this case, f of x, is equal to some sort of combination, some n choose x. Remember, anytime we're dealing with combination, we're dealing with a case where the order does not matter. And that's true. We don't really care if we're looking to see what's the probability that exactly 2 customers out of these 36 will overdraft. We don't care the order. We don't care that customer 1 overdrafted first and then customer 2 or vice versa. And so we're taking this combination, multiplying it times the probability of overdrawing or of being charged this fee to the power of x times 1 minus the probability to the power of n minus x. So the probability of not overdrafting to the power of the number of people in this sample who won't be charged an overdraft fee. And if you remember the multiplication rule here of probabilities, this makes sense, taking the power to x or the power to n minus x. So in this case, we're just taking everything we're given in the problem and plugging it in. So in this case, n, maybe I'll do this to the side, n is equal to 36. That's our random sample. And x is equal to 2. So we're going to find 36, choose 2, times the probability, which is 0.03 to the power of 2, times the remaining probability of not overdrafting, which is 0.97, to the power of 36 minus 2, or the power of 34. So you should be familiar with how to do these types of operations. And I guess in this case, we'll say the probability is approximately 0.1585. Or you can think of this as a 15.85% probability that exactly 2 customers out of this random sample of 36 will be charged an overdraft fee in this month. A few other questions that we might find relevant for the binomial distribution. We might want to know, what is the mean? In other words, what's the expected value of x, which is equal to mu? And this is equal to n times p, which for us is 36 times 0.03, which is 1.08 customers. So in on average, in a random sample of 36, approximately one customer we would expect one customer to be charged an overdraft fee on average. And let's also calculate the variance of x, or sigma squared. And this is equal to n times p times 1 minus p. And just filling in what we've got here, 36 times 0.03 times 0.97 gives us approximately 1.0476, which is important because this basically tells us the shape of this binomial probability distribution. All right, I'll pause it and get the next question ready.